Bismillahirrahmanirrahim. In this lecture we are going to continue with exercise 2.1. We had done question up till question number 7 in the previous videos. Now we will try question number 8, 9, 10. Question number 8 is show that the roots of the following equations are rational. We are given two equations, okay, and we have to show that their roots are rational. Both these equations are quadratic. I will do the second one, and in this by using the same method you can attempt the first part. So let me write the question first. What we have to do is we have to prove that the roots of the equations which is given to us. The equation is question number 8 part 2. The equation is a plus 2b whole x square plus twice of a plus b plus c x plus a plus 2c equals to 0. This is the question. A plus 2b x square plus 2 into a plus b plus c x plus a plus 2c. So we have to prove that the roots of this equation are rational. Now, as we did in our first video, first lecture about nature of quadratic roots, we learned that the roots are rational if the discriminant is a perfect square. So to prove that the roots of this equations are rational, we have to prove that the discriminant is a perfect square. So let's start. Now solution. Now we know that the roots of a quadratic equations are rational if the discriminant, which is b square minus 4, over here I am going to use capital letters because we have already small letters in the question. If b square minus 4ac, which is called the discriminant, is a perfect square. Okay, so they want us to prove that the roots of this equation are rational, and we know that roots are rational if and only if b square minus 4ac is a perfect square. So we have to prove that b square minus 4ac is a perfect square. For that, first of all, obviously we are going to calculate b square minus 4ac. Now in this equation, the coefficient of x square is a plus 2b, which is a. Okay, the coefficient of x is b, which is twice of a plus b plus c, okay, which is capital B, and the constant term is a plus 2c. Okay, so a is this, b is this, and c is this for this equation. Okay, we know the coefficients of x square, x and constant. Now we are going to calculate b square minus 4ac. For that, this will be equal to b square will be twice of a plus b plus c whole square. This is b square minus 4. A is a plus 2b, 4a into c. Okay, 4ac. Now opening this up, this will be 4. 2 square is 4, and a plus b whole square minus 4. Now multiplying these two, we are going to get a square plus 2ac plus 2ab plus 4bc. Okay, this is the product of these two. Bracket is this, a square 2ac plus 2ab plus 4bc. Now opening this bracket by using the formula a plus b whole square that we have already learned in class 9. This will be equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca minus 4a square opening this bracket minus 8ac minus 8ab minus 16bc. Okay, now let us see. Now multiplying 4 with this equation, we are going to get 4a square plus 4b square plus 4c square plus 8ab plus 8bc plus 8ca minus 4a square minus 8ac minus 8ab minus 16bc. So now our aim is to show that this expression is a perfect square, means to show that this expression is a square of some other expression. We have to write it as a whole square of some expression. Okay, 4, this will be cancelled out with this one. Okay, and over here 4a square is cancelled out with 4a square. 8ab, this will also be cancelled out. 8ac plus ac will be cancelled out. The only thing left is 8bc minus 16bc, which is negative 8bc, and 4b square and 4c square. Okay, so we are left with the terms 4b square plus 4c square minus 8bc. Okay, if I take 4 common from this, what we are going to get? b square plus c square minus 2bc, and you know that this is the square of 4b minus c whole square, and this whole expression can be written as 2b minus c whole square. So what do we have here? We have proved that b square minus 4ac is the square of 2 into b minus c whole square. As it is a perfect square, so this implies that the discriminant is a perfect square, which implies that as the discriminant is a perfect square, so this implies that roots are rational, and this is what they wanted us to prove the roots are rational. We know that roots are rational if and only if the discriminant is a perfect square. So we calculated b square minus 4ac and proved it to be equal to a perfect square. So as the discriminant is a perfect square, it means the roots are real. Okay, this is the theory that we had done in the first lecture. Now question number 9. Question number 9 is, for all values of k, prove that the roots of the equation, this is the equation given to us, we have to prove that the roots of this equation are always real. Okay, for all value of k, it means independent upon the value of k, this equation always has real roots, whatever the value of k is other than 0. So we have to prove that the roots of this equations are real. For that we need to prove that we know that roots are real only when the discriminant is greater than 0. So we have to prove that discriminant of this expression is greater than 0. So let me write the question first. The equation is question number 9. The equation is x square minus 2 k plus 1 over k x plus 4 is equal to 0. We have to prove that the roots are real. Now the solution, we know that roots are real if and only if the discriminant b square minus 4ac is positive. Okay, if the discriminant is positive, then it means that the roots of this equation are real. So I'm going to calculate the discriminant and prove that the discriminant is a positive number. Okay, independent upon the value of k, whatever the value of k we get, we are always going to get the b square. We are always going to get b square minus 4ac as a positive number. We have to prove that this is positive in all the cases. For this, so obviously we have to calculate the value of b square minus 4ac so that we can judge whether it can be negative for some value or not. Okay, so b square is over here. If you observe this equation, a is 1, b is negative twice k plus 1 over k, and c is 4. Okay, so we have to calculate b square minus 4ac. In order to calculate b square minus 4ac, let me put the values in this expression. B is this expression, so I am going to square it. This is b square for this equation minus 4 a into c. Okay, now we know that 2 square is 4, and this will be k plus 1 over k whole square minus 4 fours are 16. We have to prove that this expression is always positive. Over here we can't say anything about its positivity now, because we don't know whether this k is an unknown number. Okay, so we don't know whether this expression will be less than 16 or greater than 16. If it is greater than 16, then we can easily say that this whole thing will be positive, because a number greater than 16 minus some minus 16 will always be positive, because this number is greater than 16. Okay, but if this number is less than 16, then this expression will give a negative answer. So we can't say anything about its positivity at this stage. We have to transform it into some other form so that we are very much sure about its positivity. Even then we can say that it is going to be positive. Otherwise, at this stage we can't decide anything about it, because an unknown k is involved. Let me open this bracket and let's see if we can do anything about it. K square plus 2k into 1 over k minus 16. Now this is 4 times k square plus 1 over k square plus 2 minus 16. Minus 14. Now somehow we have to prove that this expression is a perfect square, a positive expression. Okay, we have to prove that this is a positive expression. Okay, over here we had k square plus 1 over k square plus 2 times k. We had a bracket over here. The bracket was not over there, therefore these two steps are wrong. I will erase them. Okay, and I will start from here again. Now this was, do note down that these two steps are not correct, because the bracket was not over here. I mistakenly put it over here. I will do the correction. The bracket is after this expression, so we are getting the expression. Let me erase that and start it from here again. Okay, after opening this bracket, what do we get? 4 k square plus 1 over k square plus 2 minus 16. Okay, so what we were doing, this is 4 k square plus 4 over k square plus 8 minus 16. This will be equal to, now this can be written as 2k whole square. This can be written as 2 by k whole square, and negative 8 can be written as 2 times a into b. If I write the product of 2ab over here, what do we get? K will be cancelled out with k, and 2 2s are 4, 4 2s are 8. It means 8 can be written as a product of 2 and these two. And as you may see, this is the formula a square plus b square minus 2ab. It means that we can write it as 2k minus 2 over k whole square. Now we know that this discriminant is equal to 2k minus 2 over k. Now whatever the value inside the bracket is, we know that this value can never be a negative number. This is always greater than 0. Why? Because square of a number can never be a negative number. Okay, because square of a real number is always always positive. So it means that the discriminant, we have calculated the discriminant, okay, and after doing all the calculation, we got a number which is always greater than 0. So as the discriminant is positive, we have proved it here, it means that the roots are going to be real, because we know that the roots are real when the discriminant is greater than 0, and we have proved that for this expression the discriminant is always greater than 0 by doing all this calculation and making this expression equal to an expression of square of some number, and we know the square of any number can never be a negative number. So it means the discriminant will always be greater than 0 whatever the value of k we use over here. The value of k is not affecting the positivity of this expression, because it is inside the bracket, and whatever we get inside the bracket, whether negative whether positive, the answer after squaring will always be a positive real number. So as the discriminant is greater than 0, this proves that the roots are real. Okay, so write the square of a real number is always positive. So after this, just write the conclusion that as b square minus 4ac came out to be a positive number, so the roots are always going to be real. Okay, so we have proved that the discriminant as b square minus 4ac is always greater than 0. This implies that the roots are going to be real numbers. Okay, so this is how you do this question. Now let's move to the next question. That's question number 10, and the last question of this exercise. Question number 10 is, show that the roots of the equation b minus cx square plus c minus ax plus, this is a quadratic equation, we have to show that its roots are real. This is same as question number 9. Okay, we have to show that b square minus 4ac is a positive number. So let me write the equation. The equation is b minus c x square plus c minus a x plus a minus b equals to 0. We have to show that the roots of this equation are real. Now we know that roots are real if and only if the discriminant b square minus 4ac is greater than 0. Okay, so we have to prove, in order to prove that the roots are real, we just have to prove that the discriminant is greater than 0. Over here, a, which is the coefficient of x square, is b minus c, b is c minus a, and capital C is a minus b. Okay, this is the constant term. This is b because it is the coefficient of x. This is a because it is the coefficient of x square. Okay, we have to calculate b square minus 4ac, same as we did in question number 9, and we are going to somehow prove or transform that expression into a form which gives us an obvious indication that this expression is positive. Okay, so b square minus 4ac, b square will be c minus a whole square, minus 4, a will be b minus c, and c will be a minus b. Now opening this bracket, this will be c square plus a square minus 2ac minus 4, and this will be multiplying these two, b into a will be ab or ba, that is the same thing, minus b square minus ac plus bc. Okay, so we have to prove that this whole expression is a positive number. Okay, at this stage we can't say anything because over here we have a negative sign. Okay, and we know that the sum of a negative and positive number can be negative if this number is less than this expression. So over here it's too early to say anything about its positivity, so I am going to transform this expression into an expression which will give us a very, until we get a very obvious sign that this expression will always give you positive. Let me check the multiplication again. Okay, it is correct. C square plus a square plus 4b square. I have written this 4b square over here. Now 4ac minus 2ac will be plus 2ac and minus 4ab, and what else we have, minus 4bc. I have added these two. Okay, 4ac minus 2ac, 4ab is minus 4ab is over here, minus 4bc over here. Now as it has 3 squares, so it may be a formula for a plus c plus 2b whole square. Let me write it as a square plus c square plus 4bc can be written as this. Now let me open the formula, this formula. We know that a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Let me judge whether this whole expression is the square of a plus c plus 2b whole square or not. Okay, there may be a change of sign. I will have to take one of these negative, because as you may see there are negative numbers also. Okay, so it means that one of them must be negative. Let me write it as, now plus 2ac, this can be written as plus 2 times a into minus 2b. We can write it as this, minus plus minus 2 2s are 4, and this can be written as twice a into negative 2b, and over here this minus 4abc can be written as twice of c into minus 2b. Okay, so as you may see, a square plus c square plus 2b square yes 2b square 2ac plus 2ab plus 2ca. If you compare this whole expression and this 2b can be written as, this 4b square can be written as minus 2b square. So if you compare this equation with the formula a plus b whole square, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. If I compare these two formulas, what do I get? A square plus b square plus, if in place of c we have negative 2b, c square plus 2a into c. This term is this one, 2ab, okay, 2a into b, 2a into b plus 2a into c plus 2ac is this term, and 2bc, 2b into c, 2b into c is this term. So it means that this is actually the formula of The above is a plus c minus 2b whole square. Okay, if I open this formula by using this expression, or let me write it as plus this can be written as a plus c plus minus 2b whole square. Okay, if I open this formula by using this a plus b, taking c as -2, taking b as c, and taking a as, I'm getting the same expression. Okay, so it means that this whole expression is equal to a plus c minus 2b whole square, which is always greater than 0, and this is what we required to prove. This implies that the discriminant is always positive, and which shows that the roots are real for this equation. So we had to prove that the roots of this equation are real, and the technique that we have used is that we have proved that b square minus 4ac is greater than 0. We calculated b square minus 4ac, and it came out to be equal to the square of some expression. Whatever number inside this we have, we know that the square will always be greater than 0. Okay, so this completes the exercise.